Greetings to all. This is week 2, asynchronous session 3 about drive circuits and control of stepper motors. The topics are drive requirements, constant voltage LR drive, constant force LR drive, chopper drive, open loop control, and closed loop control. The stepper motor drives are meant for supplying the current to the phase winding quickly, that is energization, the fast manner. And also during turn off, the demagnetization is to be performed in the outgoing phases, not affecting the incoming phase. So that it has to suppress the current during turn off. That should be a fast to TK. So this is the simplest driver circuit of the stepper motor with the resistance connected. That is not resistance, it is resistance of the winding and inductance of the winding only. The diode is connected for the suppression. Okay, so it provides path for the dissipation during turn off. So low and high stepping rates are shown here. You can see low stepping rates, no problem of the current increases to the maximum value and decay. But anyhow, it takes time for current decay. Okay, but in the high stepping rate, the current is not reaching the maximum, neither reaching the maximum nor reaching the zero. So we don't have the sufficient time to demagnetize and to increase the current during turn on also. So this drawback is actually taken care of in the next circuit. So in this current waveforms, we can see the things what we have discussed earlier. We provide immediate pulses so that doesn't have the required time to decay to the zero value. Okay, so the problem with this above drive is for high speed ratings there is no time for decay. So for that we add the series resistance RF here. Okay, so this resistance will improve the performance. So because the time constant L by R, okay, by increasing R, so the time constant is reduced, so it is decaying fast. So not only the power is dissipated in the resistance, also it is decaying the current fastly. So the suppression takes much faster. Okay, so that is the difference here. The current forced drive with series connected RF. Okay, so normally the RF value is chosen for the required current for maintaining such current. VF divided by R plus RF will provide the current, that is the rating of the machine is maintained. Okay, so the torque is improved when you force full current. This is a chopper drive. When you sense the current, we set the two limits, upper and lower limits. It is continuously switched on and off, sensing the lower limit of the current and higher limit of the current. It is switched on and switched off respectively. So we can see the stepping and the current jumping to the values. The chopper drives uses high voltage power supply for rapid change the current switched between the two current limits. During the off period, the energy is fed back using the diode to the source. Okay, so the pull-out torque for different, that is drives we have seen so far now: constant voltage drive, current force drive, and chopper drive. So looking at this, the chopper drive is superior. That's what mentioned here. So the chopper drive is available in single chip for 1 to 2 amps and plug-in cards up to 10 amperes. Okay. So the control aspects, we have two types. One is open loop control and next one is closed loop control. The open loop control is, that is inherently stepper motors are meant for open loop controls and servo motors are meant for closed loop control. Okay, so if you take your wristwatch that is continuously revolving at constant speed, the time is set already. What is the pulse rate? That is set. So 1 displacement per second. We have 60 displacement in the wristwatch, right? So that is open loop. We already set the time. There is no sensing at all. So that is only pulses are supplied as per the reference, and direction signal is already given. So based on that, it is continuously revolving. That is open loop control based on only input signal, that is particularly direction and speed. Okay. The closed loop is required in some applications to maintain the particular position and to not to allow the current to the dangerous limit, and speed also, rate also, because it has to maintain not to lose the synchronism. Okay. So in that cases, there are sensors used continuously monitored, and if there is an error, that is the sequence, the excitation sequence control, the pulse width or the duration is altered. So this is closed loop control in some precise applications. Okay. Thank you.